Otitis media is one of the most common diseases around the world, particularly in children. Most people refer to otitis media as the common ear disease. However, there are several forms of otitis media. Among the most common is acute otitis media. The Center for Disease Control estimates that approximately 2.4 million healthcare visits per year result in a diagnosis of acute otitis media, which is only one specific form of the disease. However, the early diagnosis of this disease is crucial for an optimal prognosis. Furthermore, it is also equally important for the diagnosis of the disease to be accurate. If a patient is wrongly diagnosed with acute otitis media, they may end up taking the wrong antibiotics, which could result in harmful side effects. However, it is equally important to know when the antibiotics are necessary. If symptoms are left unaddressed, then acute otitis media can result in permanent damage in the tympanic membrane, which is a layer of tissue that receives sound vibrations. Although this disease does not directly result in fatalities, its consequences could be nearly as severe in certain rare circumstances. Our goal is to completely remove the possibility of long-term damage by providing an inexpensive smartphone application to provide an almost immediate diagnosis of acute otitis media.
Current otitis media diagnoses require a professional medical worker to personally examine the patient's ear using expensive equipment. Thus, many developing countries do not have a sufficient number of doctors to service the population, and also lack the expensive equipment needed to diagnose otitis media. For example, Nigeria has a doctor-to-patient ratio of 1 to 25,000, which means that thousands of people do not have access to a doctor. In addition, many of the doctors are not trained ear, nose, throat, ENT specialists, which means that there could be a substantial amount of incorrect diagnoses. Therefore, a more cost-effective and accessible solution is needed. Our product is accessible even in developing countries, as the only requirements for our product is a phone with a camera. No medical professional or expensive equipment is required. Also, our product is cost-effective as it uses 3D printing while being easy to use. Our product only requires a couple of pictures that can be taken by anyone without medical training. Our results are also easy to understand for the patient because our machine learning diagnosis will conclusively inform the patient whether or not otitis media has been contracted. OtoFind is composed of two main parts: a free, easy-to-use smartphone application and a smartphone attachable otoscope. The otoscope helps the phone take an accurate image of the eardrum and tympanic membrane. Our team created an image recognition algorithm using deep learning to detect whether a patient's eardrum contains signs of otitis media. We were able to predict this with 84% accuracy, which is slightly higher than that of a pediatrician. Our machine learning model is hosted on a free iOS or Android application. However, the user must buy the specific otoscope attachment for their phone. These attachments are cheap, as they are 3D printed clip-on otoscopes. With these two components, they can take an image of their eardrum, and the application will pass it through our machine learning model, which will return a diagnosis. Furthermore, based on the confidence of our prediction, we will provide next steps for the patient. Compared to the typical diagnosis of otitis media, which requires expensive equipment as well as a visit to a doctor, our product allows for a quick, inexpensive diagnosis. Our product costs $21.69 to make and has a markup over 50%, resulting in a market price of $44.99. Our app is free for individuals, but must be licensed by companies, as our product works with any mobile otoscope, not just our product.
The attachment is composed of three distinct parts: the auto mount, the auto lens, and the speculum. The long portion of the 3D printed auto mount is first aligned with the primary camera of the mobile device before an adjustable slider is inserted to secure the rest of the attachment to the device. Next, the auto lens, containing a convex glass mirror and a threaded fitting, is screwed into the auto mount before a recyclable or disposable speculum is screwed into the auto lens, completing the attachment.
Our app is designed to be easy to use, completely offline, and accurate. In order for a user to use our app, they simply have to press the camera icon, take or choose a photo, and in the background, the app loads a machine learning model, applies it to the image, and shows the user the results. Our machine learning model runs very quickly and is designed to work on almost all iOS and Android phones, including older phones. Based on the confidence of our diagnosis, we will also provide next steps for the user.